One of the things that's going to happen once we actually get the neck routed is it's going to start becoming kind of hard to sand in the area where the neck pocket is. One of the reasons is our neck's going to sit deep enough in there that balancing and keeping things flat in that area when sanding and not kind of rounding over your pocket corners gets difficult. So I try and get it down to about 320 in the whole area where I'm around the neck before I actually route the pocket. Alright, so we are ready to start thinking about setting the neck, and we're going to learn the easy method first. Well, not necessarily the easy method, but the method that's going to work with only flat top guitars. Technically it works if the neck needs an angle, but I'll get into that later. We're going to do just a simple non-angled pocket, flat top guitar, etc. So there's a couple things that I do. I mark a line on the side of the neck where I want that side of the neck to connect to the body. In general, I have 2 frets inside the neck. This is going to get trimmed a bit if you're wondering why there's a fret slot there, but nothing on it. But I want 2 frets inside the neck, so this is where I want it to connect on the horn side. I also did a center line on the bottom of the neck, as well as just down there on the tip. And I also have my center line on my body as well. And all I'm going to do for right now is I'm just going to kind of scoot the body to the edge of the table, because I'm going to want to be able to see underneath where the neck is going as well as on top of where the neck is going. Because what I'm going to do is I'm just going to keep a squeeze clamp handy, and I'm going to do my best to line up all 3 points. So center line on the end of the neck, center line on the back of the neck where it touches the body, and this point here on the side. And I'm going to do my best to clamp it in that spot. So I got 2. A little off on the bottom. There we go. So now I have my center line on the top, my center line on the back, and I've got this lined up on the side where I would like it to be. Alright, so I'm going to do a couple things, just so that if I lose this in the future, I can get back to it pretty easily. I'm going to mark out where this sits along everything. And also on the back. This is just going to allow me to quickly re-reference everything if I need to in the future. And now I'm going to attempt to get this clamped in place so it doesn't move on me at all. Oh, and as always, before doing steps like this, always make sure that your neck is straight. So obviously I checked my level before and adjusted the truss rod as needed. Although this is a decently accurate way of getting your center line lined up, especially if you have a long tenon like I've left so far, I will be trimming that off. But we are going to be a little more meticulous in our measurements. So what I'm going to do is from the end of the neck, I'm going to measure out along our center line 6 inches, or well, whatever measurement you see fit. And then I'm going to, using 2 opposite sides where I have lines in the same direction, I'm going to draw a perpendicular. What that's going to allow me to do is it's going to allow me to take my ruler and project where each side of the neck crosses this line I just made. The reason we want to know that is because the farther away from the neck that we get, the more accurate we're going to be able to tell if the neck is centered. So by projecting this line, I'm giving myself further from the neck to measure at, where the 2 crosses are. I want to make sure they're centered. So so in total they are 2 inches and 12/32. So we would expect it to be at 1 and 6/32 for the center. And that is exactly what we see. We have 1 and 6/32 for my center. So now let's talk about the actual method that we're going to use to start routing this pocket. What we're going to use is some freshly jointed stock. It doesn't actually have to be jointed, sorry. You can send it through your table saw. I'm just using 3/4 MDF that both sides were freshly table sawn. And basically all we're going to do is we're going to use this double stick on one side on either side of the neck, and that is what our router bearing is going to follow while we route out the shape. We're going to do one on each side and a stop at the end for how long we want the neck to be. As I mentioned earlier, I will be trimming this before we get into that. So first things first, I'm just going to measure a couple pieces. You want on both sides it to go all the way off of the body a little bit and all the way to the end of your tenon. So there's my first piece. And the second piece, out of the way. So it's about there. My end piece needs to not get in the way of either of the rails that stick out past the neck. So I want it to be just less wide than these other pieces. So I'm going to cut it right about there. I'm now going to trim my tenon to the length that I want. In general, I try and keep as much as possible. I like the energy transfer and all that stability added by having a nice long heel. Your determining factors are really going to be where your neck pickup sits and whether you have a pick guard. Because as long as you have the neck pickup covering the end of your tenon, no one's ever going to see it. Same with the pick guard. So in this case, I have a telly style body, but done in my shape, and I only have a single coil pickup. So if I wasn't going to have a pick guard, I really couldn't let it extend any further than about there on the body, because I don't want it to show up. However, my pick guard goes all the way back almost until this bridge pickup here. It's going to have traditional telly style pick guard and bridge. So what I can do is just take a little bit off the end and leave myself a nice long tenon, since it's going to be hidden anyways. You can usually get away with almost 2 inches if you have a neck humbucker, but you'll just have to play it by ear for whatever style build you are doing. You don't have to do this with a handsaw. A lot of people will cut it with table saw, band saw, chop saw, whatever works for you. I just happen to be in the indoor shop, so I only have my hand tools here. Alright, now we're back, and I have added a second clamp to keep things from twisting. I've got everything perfectly lined out, and we are ready to start building up the template to route with. I'm just going to use double stick carpet tape. In this case it's Duck brand, but Sureline also makes a really good double stick carpet tape. It's the kind that's got this like fibery weave to it that I really like. Go ahead, put ourselves a nice long piece off that'll span the entire length of this rail that we've built. Well, almost the entire length. Give myself a half of this one. And we're literally just going to start sticking it up against the neck, but obviously stuck to the body. So up against the neck, stuck to the body. So give it some, place it, give it some sideward pressure along the neck, and push down. The next thing I need to do once I have my pocket laid out is to establish how deep the pocket needs to go. And since this neck doesn't have any angle or anything like that, I can actually just take a straight edge, project it, and measure the height at any point. It doesn't have to be at the bridge location since there's no angle going on. But I have right now a height of 1.56 inches. I know that my telly bridge has a height of 0.4 inches, so we're going to say we have our 1.56 inches minus 0.4 inches. And then we also know that that 1.5 was sitting on the frets. By the time you get out to the bridge, you're going to have had a little lift from the action. And although we don't know exactly how much the action is going to be since we haven't set up or picked our action, I can guesstimate it. And I'm going to do a safe estimate because we do have some height adjustment leeway. But I'm going to give it an additional 0.0625, so a 1/16 of an inch taken off of that. So we have 1.56 minus 0.4 minus a 1/16 of an inch. That's going to give us the full depth that our pocket needs to go down. So height of projection minus height of bridge minus a little slop for your action, but you'd always rather adjust up. It's very hard to adjust down. You'd have to route your bridge down, and we want to avoid doing something like that. So plan for how to adjust up a little bit. One thing about routers is when they follow a surface, no matter how clean, etc., everything is, if you do it in steps, it will have ever so slight variations in different passes because you're doing them in stages, as you'll see. So what we're going to do is we're going to add a little tape to the insides of your template area, just along the sides. This is for two reasons. Firstly, and most importantly, we're going to keep at least one layer of tape on until our very, very last pass. The reason for this is, if we do the tape off on our last pass, that means it's going to be taking off the full height in one pass, but very, very little, just the thickness of tape. That means any of those slight variations that we had when doing our multi-levels, working our way down, those are going to be dealt with on that last pass. I'm also going to add 1 second layer of tape, and I'm going to keep that through the entire process. Even at the end, I'm going to keep that there. The reason for this is I want a little tighter pocket than the actual neck. That way, it's going to, a little tighter is going to push the neck ever so slightly towards the bridge. So it's going to be set in a little further than I actually meant it to. What this allows me to do is it takes a little bit of sanding, and I can just fine tune where that neck sits by sanding a little bit off the sides after the pocket is done. And I like to have that leeway. Alright, one layer down. Time for a second layer. With our eye protection on, something holding it, weighting it down a bit. I'm using carpet to protect the back. But with all this stuff ready, we're going to go and do a shallow pass with a small bit. We don't want to take too much at the same time, so I'm going to use a small bit for now, and I'll switch out to a larger bit if I need it for the depth. I've already set the height to make sure that my bearing will be following, that this will be cutting the depth that I want, and I'm just going to do a shallow initial pass. Since I already have my net pocket routed, I'm going to start in that pocket and work my way through the back area, and then I'm going to come out here and back in there. The reason I'm doing that is because the way that it rotates. You want to kind of use the router to its best advantages so it doesn't grab, etc., and chip things out. So once again, it's sort of a clockwise motion. Going in on this side, around, out on this side. In, out. In on the left, out on the right. That will help you prevent chip out. Not a huge deal here because this is all in grain, but if you have a guitar with bent sides or a binding scheme, that's no longer in grain there, that's the binding coming in like this, so you got to be very careful with the way that you run your bits. As you can see, it gets a little messy, but here I've done part. Here I've done part of the pocket. I just wanted to show that there because I'm I'm going to turn it off for a while and just do the work because this is going to be relatively slow, but I wanted to show you a little bit of that process. One other thing to keep in mind is always watch where you're supporting your base, because you have extra distance here that you don't have on this side, and you don't really want this sticking out really far, because if you accidentally come all the way out and you push on it, you can pop that up and you just ruined your template. So do be consciously aware of where you are putting pressure of the base to keep it steady. As you can see, I've done a few passes with my smaller bit. Right now I'm at about a pocket depth of 0.6, so I'm only about halfway, but I am reaching the limits of my smaller bit, so I'm going to go ahead and switch out to a larger bit now, this guy, and as you'll see here, this is why I'm switching now. With the bearing riding all the way up towards the edge, I have about what I want for a depth of cut for a first pass with a bit. So now's a good time to switch. Plus the 1/2 inch diameter bits are sturdier and nicer. You can really power through things a lot better with them than you can the 1/4 inch bits like I started with. 1/4 inch shaft bit. I've now gotten down to the point of my last pass. So what I've done is I've actually measured out where that full depth is, and I'm going to use that to set my router bit depth for the final pass on, and also now is the time to go through and pull those the second pieces of tape. I already did this side, so I am ready to go. I just need to set my bit height. Okay. A little bit more. Just wanted to be able to see. And there's our pocket. And it is exactly 1.2 inches deep. So I am done. Ooh, these are really good. Stick on there. So now that the pocket's done, I'm going to do the set neck test. And what that really is I went and I rounded the corners of the end of my pocket so that it will fit the corners left by the router bit. And all I'm going to do is I'm going to slide it into the pocket, pull it for tautness. As you can see, I have a tiny amount before my line. And this is a test of a true pocket. You pick it up. Ignore the fact that I have gap there. I left that there for a special purpose on this build. I normally wouldn't do that, but it does help to be able to kind of put it in and slide it forward. I like that, but you don't always get that luxury. I have my pick guard, so I'm lucky here. As I mentioned earlier, you can also use this technique to do an angled pocket if you have to. Once again, it only really works on flat top guitars still. But you can do an angled pocket with the method we just saw. The only extra step you have to do is, instead of routing your pocket into the body, you first do all the steps necessary to route a pocket, but you just do it in some 3/4 MDF. And what this is going to allow you to do is it's going to allow you to place it on your body and then angle it. However, I want to point out one last thing about this method. As you just saw, when I tried to angle this, it didn't come up straight like this. It actually came up at an angle. The reason for this is because your forwardmost points are not a straight line. And that's what this template's going to register on, is where the two forwardmost points that it hits. So basically you have to artificially create two higher, perpendicular to the center line points for it to pivot against. So essentially all you're doing is you're going to take two shims, you're going to place one at the end, one somewhere a little further back, and your template's going to rest on those, and you can clamp them like that. Obviously this is going to be a 0 angle because these two shims are the same height, but you can play with the height of those shims to change your neck angle as needed. You can either draw this out on some paper and do some measurements to find out what the two are and where they need to be sitting on the template to give you the correct angle, or you can also do some trigonometry to figure that out. This is what's called a mica neck jig, named after the guy that invented it or designed it, the David Mica of Mica Guitars. What it allows you to do is it allows you to route neck pockets at angles as well as on carve tops where you don't have a flat plane that you can register a template to. I'm going to quickly go through the different parts of this jig, explain why they're included, and then we're going to go into actually routing it. Not all base plates will have an angle adjust, but my friend built that into this one. As you can see, it's hinged back here on the edge. And what that allows you to do is allows you to change the angle that the body sits at while the rails stay constant, these rails here. And that's going to allow you to do variable angle neck pockets. So if you do a lot of different body shapes, bridge styles, etc., that's something that you may want to put into your jig. The rails sit perfectly coplanar and are locked down using these bolts here with locks on the bottom as well. And what that allows you to do is it allows you to clamp the neck between the two rails with the body on that plate, and then you can go about removing the neck, locking down the rails, and routing to that shape. So as you see, I have my body bolted down very tightly to the jig, and I've initially set it at 2.5 degree for the neck angle and tightened those down on both sides. That may not be where it ends up, but it's a good place to start. The next step is just like we saw before when we routed our neck using the other method. We need to have those points of interest for us to register off of. So I'm once again going to draw a line where I want the neck connecting to the body. Actually, this is the only point of reference we need for this one. Apologies. We don't actually need the center lines because the jig is going to take care of that on our behalf. So all we need to do is line this up to where we have about that point touching the edge of the body. And then we're actually going to clamp this into the jig. One thing to keep in mind is during this process, you should never clamp where you do not have a full heel. So anywhere where the neck starts to get carved, don't put a clamp there. What that's going to do is when you pull the clamps off after you've locked the rails down, it's going to make it so that you could have like a bend or a warp in your in the rails that was held there by the clamps, and when you let it off, it kind of goes out and you have a bad pocket. So you have to be careful only to clamp where you have a full flat tenon. That's why I don't trim my tenon to the full length, final length before I do this process, because I like having that extra tenon amount to play with. One thing I am going to do is I'm going to do my best to approximate the neck so that it's parallel with these the rails. So for me, I've chosen to have the bottom edge of the fretboard go flat along these rails. I'm going to get one more clamp in here. Once again, looking for where my carve stops, which is outside the body. So I know I'm safe to do it here. Alright, so that's step one. If I had a little more height before the neck started touching the body, I could have just lined up the edge of the fretboard with the edge of the rails. Everyone would have been happy. I would have known they're parallel, but so this is my friend's jig, and he builds guitars slightly differently than I do. He doesn't have it as tall as I need for mine, so I'm actually going to use this angle counter, and I'm just going to zero it on the rail, zero it on the rail, and place it on here. They should match. So now that we have the neck clamped and ready to go, we need to actually line it up so that it's centered with the body. And this is one of the great things about this jig, is you don't really have to have everything centered on the jig. You just have to register the neck to the body, and that makes it a little simpler than some of the other jigs out there. And the way we're going to do this is we know that these rails are parallel with the edge of the neck. So what we can do is we can take a ruler, put it underneath these rails, and at two different spots we're going to angle that ruler up so that we can see where it contacts the bottom of these rails. And what that's going to allow us to do is it's going to allow us at a point near the neck and a point near the tail to make it so they're perfectly centered on the center line of our body. Since these are parallel to the edge of the neck, that also means the neck is now centered to the body. Once you have those two things laid out and everything's perfectly centered with one another, you lock down the locks at the end of each rail. And we can actually then remove the neck, as we'll see in a little bit. One thing that I have found kind of handy is if you get one area, one point centered, so either the tail or near the neck, you can lock down like one of these and kind of pivot on that. It helps a little bit, but this does take some time, so I'm not going to do it on video. But basically it's just kind of playing around and shifting things ever so slightly until everything is just perfectly lined up. Okay, so I now have them centered and I've locked down my locks. So basically all I did was I came in here and I made sure that that 6-inch mark was lined up on both sides of the ruler on my center line. As you can see, I just put some scraps along the center line to boost it up because my ruler is pretty thin. But basically, sorry, I'm going to use my machinist rule side. But basically all I'm doing is I'm lining those up and I'm rotating the ruler forward, and I'm seeing that on either side of that 6-inch mark I'm hitting the rails at 1.2 inches, so it's centered 1.2 inches to each rail. And then I did the exact same thing over here, except obviously it's a lesser measurement because it's closer to the neck and tapers out. And that's it. That's how I centered everything. Once centered, I locked it down. Remember, we are working to very, very tight tolerances here, so that's why I use a machinist's rule, because it has the accuracy that I need. Also, I straightened my neck with the truss rod before we did this, as usual with any neck-oriented work. What I'm going to do is I'm going to take a straight edge and I'm going to project it down the fingerboard. I know the scale, so I'm going to make sure that the full scale length I have at the end of the ruler down here, and I'm leaving that at my nut. And then meanwhile, down here, I'm measuring with a ruler right at where the bridge will be on the center line. And it's saying that I'm projecting out at about 2 inches, 2.05 inches. So, what that tells me is that everything on this neck needs to go down 2.5 inches minus the height of the bridge. In my case, I have a 1/2 inch tall bridge. What that means is I'm going to have to set this neck from where it sits now down an additional 1.55 inches. So what I'm going to do now is I'm going to go to the end of this neck, and from the body upward I'm going to measure 1.55, and that actually puts it level with the top of the neck blank, not the fretboard, but the neck blank's tenon. I actually want my neck to sit up a little more than that, so what I'm going to do is I'm going to change my angle. If I would like my neck to sit up a little more, what I'm going to do is lower the angle right now I have a projection above the center line where my bridge is going to be of a little under 2¼ inches. It's about 2.22 inches. I have a 1/2 inch tall bridge. So what that means is it's projecting out 2.22 inches, but my bridge is taking up about a 1/2 inch of that. So really the number I'm interested in there is 1.7 inches. So projection minus bridge height. What I'm going to do is I'm going to go now and measure from the top of the body up the side, up the end of the neck and see where that puts me. So that leaves me about 0.15 inches of the actual rosewood material plus the fretboard sticking above the body. And that's actually what I'm looking for. I like that number. I like my fretboards to sit a little higher than just the fretboard, so hence why I'm leaving a little of the rosewood sticking up. Now that we have our projection, everything's centered, we know our angle, etc., etc., let's go ahead and start setting up our router. So, I use pretty big bits. This one will do most of it, but we will switch to an even longer version of this bit, 3/4 inch diameter, 1/2 inch shank, and 2 inch cutting depth. That will be the final bit we use. The only difference between the bit that's in there now is it's, I think, a 1½ inch cutting length. So it's just a little bit shorter. What I'm going to need to do now is, our projection was based on where the neck sits right now. So we know that that neck needs to come down by 1.72 inches from where it currently sits. So what that means is we need to align our router bit with the bottom of this this neck, because the neck needs to go down 1.72, and there's a gap of air underneath that neck. We need to count that gap of air. I'm just going to look underneath here and set my router so that it is the same depth as the neck. If I need to get some wood in there to kind of follow the neck so that I can really see where things are sitting, that can help as well. I've set my bit and locked everything to where it needs, where it matches up at the bottom of my neck heel. I've registered that on my depth stops. Once I actually get into the pocket, that's going to be a better way to measure, but we'll see that in a minute. But the key thing is I now have this registered, so I can actually go ahead and finally remove my neck. Oh, and I also marked where my fretboard ends. That's going to be key. Okay, so my neck's out, and we are going to have the tenon continue under the neck pickup. The neck pickup, a humbucker is about 1.5 inches long in terms of the way the strings go. So I'm putting a neck humbucker in this guitar. So I'm going to take where my fretboard ends and measure about 1.5 inches. I'm going to connect those lines. So, if the humbucker's 1.5 inches, and we need a little extra space for the neck side of the humbucker ring that it's going to sit in, that means if I project out 1.5 inches, that the humbucker will actually sit a little further and still cover our tenon. But that's where the pocket needs to end. However, this router doesn't really work like that. It's not just going to stop where you tell it to. We need to give it a reason to stop. And so I'm going to measure from the flat side of my router to where the bit finally hits, the furthest most point. And that is 2.35 at 2.4, sorry. 2.4 inches. So what that means is from where I want the tenon to end, that line I just drew, I need an additional 2.4 inches. Because what I'm going to do is I'm going to create a positive stop for my router base, so when it hits this, it's going to stop cutting there. I'm just going to go ahead and clamp that on with some mini clamps, nothing fancy. Okay, and I am going to come in and double check that it is stopping where I expect it to. So that looks about right. I'm looking for the bit to line up with my line, which is right here. So that looks great. Just like we saw in the previous template route method, I'm going to take some tape, 2 layers of tape each side, just like I did before. You'll also notice that one thing I didn't do here that I did in the last template is I didn't factor in a height increase for the fact that the ruler was sitting directly on the frets, not accurately representing the strings because of the action. The reason I didn't do that here is generally the bridges that I use on a angled neck guitar have more control over how high they sit, like Tune-O-Matic, Baby Grand, all these bridges. They have a lot more leeway. So I actually want that bridge to sit up off the body a little bit from its standard 0.5 inch height. So that's why I didn't factor in the action. That action requirement is going to lift that bridge off the body a little bit from the studs. So that's just why I didn't do it here. So we are now ready to actually begin routing. For my first cut, I am going to there's a decent amount of gap there, so I'm going to go ahead and take my positive stop, and I'm going to move it up a 1/2 inch, staying on the same notch. So this is a 1/2 inch lower than it was before, and that's not quite getting me to where I want to cut. So I'm going to move this up yet another little tiny bit and lower it down. So now I'm at my first cut level. Let's go to it. Same method of cutting that we used on the template style neck route. And obviously make sure that your bearing is following on the tape that we put. Alright, so we have our first pass. And it looks pretty good. What I'm going to do now is I'm actually going to stop measuring using my router's measurements, and I'm going to assume the drop that I did in the router. It was 1 1/4 inches. I'm going to measure that. This is going to be more accurate. So whatever depth that is right now, I'm going to call that 1 1/4, and we're going to continue going further down. So just to illustrate that point a little better, the edge of my pocket is a mere 3/32 inch deep. What that means is 1 1/4 inches actually equals 3/32. So to get my full 1.722 inch depth, I need to consider what it is now already 1 1/4. We've gone down as far as we need to, so I'm going to start pulling everything off, and we're going to check out the neck. Better be sure you're done by this point. There's no going back now. Now that we're done, we'll do the same thing we did before. We'll do a pocket test. I've also trimmed the tenon of the neck so that it is rounded and the correct length, and it'll actually fit. And the test. Also, now if you want, you can go ahead and check things. So that's the bridge I'll be using. And if I look at it, it's got a little bit to raise before it touches the ruler, and so then I'm also going to get a little bit of height from the action that the strings need. So it's right where I wanted everything. Provided we don't have a pick guard or we didn't route a channel before gluing on the top, that means we need to make a channel for the neck pickups cables to get back to the bridge pickup and into our control cavity. We need to do that now before we put that neck in, or else it's going to be very difficult. There are ways to do it if you forget, which I pretty much forget one every batch. But you can actually go through the control cavity. Basically, when you route or you drill out your end jack, you can just get a long bit, angle everything out, and make sure that your bit's going through the end pin jack, through the control cavity, and all the way to the neck pickup. It is possible. It's very stressful because you can't really see where the bit's going. You got to rely on measurements and whatnot, and you can make mistakes that way. So it's a lot easier if you remember to do it at this stage. So what we're going to do is basically the average humbucker pickup route, which is what I'm putting into this guitar, humbuckers, is about 3/4 of an inch deep. So what I'm going to do at the end of my pocket, I'm going to just mark where 3/4 of an inch deep is, or just an estimate thereof. And then what we're going to do is we're going to drill with a very long 1/4 inch drill bit from that point all the way back to where our bridge pickup will go. So essentially a little less than our end point of our scale length is where we want to go to. So basically connecting what will be the neck pickup route with what will be the bridge pickup route. Here's the kind of bit I'm referring to. It's about 1 foot long, and it really allows me to get where I need to without the drill coming into the pocket and marring up surfaces or anything like that. It also allows me to get that nice flat angle there. What I will do sometimes is I'll measure the difference from the bottom of the pocket up to where the center of the drill is going to go, and I may just make a shim that essentially just sits along the bottom. Ooh, actually that works perfectly. That way I can rest this bit on top of that and always make sure that I am drilling straight. That way I'm not having to look from the side and assure that I'm not drilling an angle up or an angle down, may cause me to pop out the top or the bottom. So just any little things you can do to help yourself out in these stages is good. But I'm going to go ahead and set up that drill, and we're going to drill that out. Alright, so I've put my neck in the pocket, I've measured where my bridge point is, and I've measured that I want about 4 inches. So there's the end of my drill, there's my scale end. So I've got some space, and that's kind of where the bridge pickup will be. So that's about where I want things. Now I'm going to go ahead and drill up to that depth stop that I put on my drill bit. I'm going to use this piece that I've thickness to the appropriate thickness like we talked about before to keep my drill bit flat, and I'm just going to go ahead and drill through. I like to drill it a little off center. That's just a preference because the cables usually aren't on center. Be sure to clear out your shavings often. The reason for that is when things start getting really shaved up in there, it can cause drills to move up or down as they go through. With a drill bit this big, it's not really that big a worry, but better safe than sorry. We're ready to actually glue in the neck into the neck pocket. Since this is a rosewood neck, I'm going to be using epoxy. You don't have to use epoxy for rosewood necks, it's just kind of something I've been into lately, so I'm going to do it on this one. For other guitars, I generally just use Titebond. I like that a lot. It's clean, it's easy. But for this one, since I am deciding to use an epoxy, I'm going to be using West Systems. I'm going to mask off all around the pocket so that squeeze out doesn't become a problem for me. And cleanup's a little easier than normal. That way when the epoxy is slightly hardened and slightly cured, I can come in and just pull the tape off and leave myself clean edges. You want to make sure that none of the tape actually sits in the pocket, because then you'll have like a slight blue line when you pull the tape and it gets stuck in there. And I've got the neck pocket and the sides of the neck, top of the neck, etc. masked off. As you'll notice, my neck is not currently fully done carving. For most intents and purposes, your neck should be ready and done at this point. I do a slightly different heel than other guitar builders, so I have a different method that I use here, but for the average guitar builder, your neck should be done and ready to go at this point. You should not have any carving left, minimal sanding should be left, etc. So basically, I'm just going to go through this, get the epoxy slathered up on the inside, press the neck in, and then we're going to clamp everything up. And obviously try and not get a lot of epoxy in the hole you drilled earlier. I am going to move this to the edge of the table. I like to use gloves here. Epoxy is a irritant to the skin and eyes and all that sort of jazz, so wearing gloves is a good idea. Also, wearing gloves kind of allows you to get your hands in there and kind of smear things around, which you might want to do. Go ahead and be fairly generous. Get on the sides, the bottom, everywhere. No starving the joint. The pocket's ready for its treatment. I'm going to go ahead and slide the neck in. I'm going to start clamping. The general procedure that you're going for here is to try and not only clamp from the top, but also clamp from the side, which you'll see as I go through. For this, I've created a caul that I sort of clamp across the waist, and then use this area to clamp that neck into the side. It's less important on double cut style builds, but on single cuts, it's a nice little added bonus that really gives you a tight joint up here at the edge. So bear in mind, unlike some other glues, epoxy isn't a a kneader of just huge clamping power. Tight bond really likes heavy clampage. The tighter the better. With epoxy, that's not necessarily the case. You want a good joint, you want some clamping pressure, but I mean, it doesn't need nearly or want nearly as much as tight bond. You want a little bit of an epoxy film left, whereas tight bond, you want to essentially try and just make the joint disappear. I'm making sure that it's sitting where I want it to. All right, put that in. If you have areas that you're afraid of squeeze out of epoxy getting onto your clamps and kind of locking them up, just standard packing tape in those areas creates a nice little barrier that you can just kind of stick on the back. It'll catch any squeeze out epoxy and not let it get onto your clamps as easily. For comparison purposes, here's a guitar that I just glued up using tight bond. As you can see, we got tight bond, and very similar clamping procedure. Just as I mentioned before, I use a couple more clamps when doing the tight bond, simply because it likes a little more clamping pressure than the epoxy does. Alright, so this has been drying for a little while. You want to try and pull off the tape when the epoxy is partially cured, so i.e. it's not fully dry yet, but you can still get the tape off. Once it's fully dried, sometimes it can be difficult to get the tape off. It'll leave stuff there that you don't want in hard corners that it's difficult to get out of. Generally what I'll do is I'll try and get as much of the tape off as I can without removing the clamps, but sometimes you will have to remove one clamp, kind of do that section, put the clamp back on, remove a different clamp, etc. But remember to take those pieces of tape off before it's fully cured, and it's so easy. The next step is, if you have any of the tenon sticking up over the surface of your body, you need to get rid of that so that it's flush with the body's top. This is a flat top, so it's pretty easy. I'm going to show you also how to do it on a carved top as well, but a lot of the things are the same. First and foremost, you probably have a little glue stuck at the end of the fretboard from when you actually put the neck, when you put the fretboard on the neck. So you don't have to be super clean here, because like I just said, the rest of this tenon is coming off down to the level of the fretboard. So really all I'm doing here is I'm just trying to get rid of some of this glue so that I have a nice crisp edge there. So the reason this crisp edge is so important to me is we'll be using a Japanese saw to do this. All you're going to do, actually, let me first talk about why I chose a Japanese saw for this method. Basically what you're going to do is you're going to cut straight downwards until you almost hit the top. Be very careful. Then you're going to come in from the side and use the top as your register to keep this flat. The reason I chose a Japanese saw is because this saw has zero rake on the teeth. So basically, if I lay this flat and I rub it back and forth, it's not marring my surface. The teeth are all in line. They don't angle out at all. So basically, any saw that does that will be good for this job, but I just happen to like this one. It's fairly fast. I said that I usually go down and then from the side, but it doesn't really matter if you go from the side first and then down. So what I'm going to do is I'm going to use the flat edge of the fretboard, so the end part, as a positive stop for 90 degrees. Because if my neck has any angle, I don't want to cut straight down, because then basically the fretboard will be angled back and then you have it down. You basically want the cut onto the tenon to be equal to the end of the fretboard, so then it just looks like a nice flat surface. So if you have a 2.5 degree back angle on your neck, this also has a 2.5 degree back angle. As you can see, I'm not really holding the blade up against the end of the fretboard anymore. That's because I've officially established a cut now, so it's going to go straight. I mean, I'm not really traveling that far. It's maybe 1/8 of an inch down to the top of the body, so once I've established that cut, it'll stay fairly straight. I can just kind of keep my eye on where the ends of this saw are so I don't nick my body. But do keep in mind that you don't have to go all the way down. All you need to do is go down far enough so that when you come in here, it comes out. Because you're also going to be taking off that much thickness from here as well. So that's about how much you can leave before hitting the top. Another tool that you see some people use for this sort of stuff is these X-Acto razor saws. They're another good choice. A little bit of a safer option simply because the teeth aren't as aggressive. But keep in mind this saw will take longer to do. Now that you've done the cut at the end of the fretboard, you can come back and do the flat part as well. Basically, all you have to do is keep the blade flat and move it around. I have found that keeping pressure on the back edge of the blade is better than keeping it on the front, because even though it has no rake, if you put a lot of pressure on the front, it may go ahead and mar your surface a little bit. So kind of light pressure on the back of the blade, nice easy pulls. I found that changing the angle that the blade is at a little bit also helps not accidentally mar your surface. And as always with tricky stuff like this, go slowly. If you really want to avoid it, what you can do is you can take some tape and basically lift up the blade by a couple thou of an inch. And that's going to make it even less likely to mar your surface. Now keep in mind, you're going to get a little bit of schmutz, but it's not the end of the world. We still haven't final sanded, so as long as you're just not doing deep gouges, that's what you want to avoid here. Deep gouges. Kind of at the end, you can just pull it off. I'll then go in with my chisel again and probably clean up the edge, because there's probably a little bit of unevenness right at the edge. We're going to go ahead and calculate the placement of our bridge now that the neck is glued in. I'm going to show you two different methods. The first uses just pretty standard tools. I'm going to take my nice straight edge, and I know that this has a 24 and a 16th inch scale, this guitar. So I'm going to set 24 at a 16th of an inch at my nut. I'm going to go down the center, and the end of this, I'm going to butt a ruler up against the end. I'm also keeping that ruler flat on the body because this is a flat top guitar. I know that that's a perfect perpendicular, straight up. The bridges don't travel in a angled motion like a neck if it has an angle. Bridges travel straight up and down. So I want my bridge to sit exactly where it needs to in an up and down sense. I don't want to take the neck angle into account when placing my bridge. Alright, so I'm going to mark that that is where the scale length sits. The other way that I can find that is this nifty little tool that StewMac sells. What it allows me to do is I place this groove on the 12th fret, and I line up the other end, this part, to where the nut sits. That way I can just flip it around, and it's going to tell me where my scale length is, and it actually matches up perfectly to where I just drew my line. Keep in mind though, all strings will have something called compensation, so the saddles will sit a little further back than scale length, and this does take that into account. That's what these two little spikes on the end are. Notice how this spike is closer than that one. That's because on a guitar your bass strings will get more compensation than your treble strings. That's treble strings. However, on a bridge like this that has a whole ton of range of motion, I'm not nearly as worried as I am on an acoustic guitar, and that's really where these are set for. I use them more on acoustics, these little things. I'm going to set this bridge to where my intonation point on the saddle is perfectly even with the scale mark that I just drew. I'm not taking into account these spikes for this one, like I said, because I have a lot of intonation room. Next, we also want to make sure that everything is perfectly lined up. Hopefully this whole time you've been building, you've been paying attention to your center lines pretty well, so it shouldn't be an issue. But just to make sure, not only am I aligning things along the center line, I'm also going to use my neck and my ruler. I'm going to go up along the neck, and I'm going to draw a line and mark where a distance I know, so I'm going to choose 6 inches from the end of the neck, and I'm going to mark that. And I'm going to flip it over. I'm going to do the same thing on the other side, mark the same place, and connecting those lines is going to tell me, it's going to help me find my center. So I can take my center of that, I can mark the distance from that line to where my scale length is, I can draw that line, and that allows me to really center things up and calculate out that I'm truly going to be putting this stuff on center. This is a fairly easy bridge to be setting. I say that because the posts are in the middle of the bridge. So this is exactly 3/4 of an inch wide, and the posts sit in the center of that 3/4 of an inch. So that makes it easy. Then I know also from measurements that the center point of the saddle, because this is a round saddle, I know the string's going to intonate and sit on the very top of that, so the center. I know that the furthest most forward point of that is 0.2 inches from the edge. So we can play a little math game here and say, okay, well, if the intonation point was the actual edge of the bridge, then this would sit back half the distance, set back from my scale length, half the distance of the bridge width, since these posts sit in the center. So let's assume that our posts need to sit 3/8 of an inch back from our scale length line. However, that would intonate at the front of the bridge. I want to intonate 0.2 inches forward, 0.2 inches further back from that, the center of this barrel saddle. So basically I need to have my posts sit 3/8 back and 0.2 forward. That means the post holes of this bridge need to sit further back than this scale length point by 0.175 inches. So they're going to be further back than the scale length. And that makes sense because the intonation point is further forward than my post holes. The last thing I need to do is to figure out along this line how far apart my post holes need to be. So what I'm going to do is I'm going to measure that, and that's 3.11 inches. That's 3.11 inches. However, that is the outsides of these posts. So the center of the post would be a half the diameter of this post in and a half the diameter of that post in. So I can take 311 and I can subtract just one diameter from that, so 235. That means that these posts need to sit apart 2.875 inches from one another along the center line. 2.875. Bear in mind that this is what I'm doing for a bridge that has a fair amount of intonation room on it. What I would do for a bridge that has a little less than this one does, so for instance maybe a tune-o-matic or so, is I will actually take those measurements and I will keep the treble side post exactly where it is, but I'll take the bass side post and I'll push that back anywhere from a 1/16 to an 1/8 of an inch. The reason for doing that is it allows you a little more room for intonation on the bass side, which usually takes more, so you're kind of just cocking it back and assuming some compensation already, because you know that those wound strings are going to take more than the treble strings will. So that just gives you a larger breadth for in the future, perhaps doing different gauges of string on this guitar, or something with some really heavy strings. So I've marked where my 2 holes hit, and the last piece of information we need is the diameter. It's 350, so I'm going to drill some 350 holes for the posts that the bridge will sit on. I've got my holes drilled, so we are now ready to pop in our inserts and see what our bridge looks like placed on the body. Obviously I'm going to countersink those into the pick guard, but I'll do that later. It's not key here. Our bridge is mounted. The process would be fairly similar if you were doing a bridge that took screw holes instead of post holes. Basically, once again, you're just finding where the bridge needs to sit and drilling appropriately, be it post holes, screw holes, routing a trem cavity. All of that follows the same procedures. You find where your intonation point is, you measure back from there to where your fastening points are, and go at it. If you're building a flat top guitar, you can actually just draw out where your pickup cavities will go, hog them out with a Forstner bit or large bit, and then basically just double stick tape your template and route as is. You don't have to go through the complex angled pickup process. So the first finish we're going to learn about is the True Oil finish. It is this product. It goes on very thin, yet it is very, very easy to apply. That's why a lot of people like it. I'm going to be showing you the way to do a satin version of it, but it is possible to do a full gloss version with True Oil as well. Because True Oil goes on so thin, I like to have things really well sanded. You don't have much filler per se. Like when you spray a nitrocellulose finish, a little bit of that is going to fill any cracks or anything like, not cracks, any sanding scratches and whatnot, and it will actually help hide them. That's why we only go up to about 320 with those kind of finishes like nitrocellulose. But with something like True Oil, you don't have as much filling capacity. So I like to sand everything higher for a True Oil finish. Minimum 400. I like to go to 600. But we are actually going to also have to pour fill. So the difference between the sanding scratches and the pour filling, you might ask, is sanding scratches, you do need them level with the rest of the surface or else you'll see them. But the interesting thing about sanding scratches is that when you spray a finish on them and level, they'll actually disappear. Whereas when you go and do a pour fill, which we're about to do, this method, it would actually highlight the scratches because we're leaving little bits of the wood mixed with the True Oil as pour filler. So it's kind of pour highlighter, and so it would also technically be scratch highlighter. That's just another reason why for this method I like to go up a little higher than usual. Fairly simple. We're just going to take a sanding block, and I'm going to show you on this test piece because I've already done this on the guitar. But we're going to take a sanding block, some 600 grit paper, and some True Oil, and literally I'm just going to apply some of that True Oil to the wood, and just like any other sanding operation, we are going to sand with the grain. And what this is doing is, even though this is fairly fine sandpaper, you see it's got some schmutz that it's leaving. It's a mixture of that fine sanding dust and the True Oil, and that's actually going to go about filling those pores. So I would go over the entire body like this, and then I would actually let that go ahead and dry. A little bit, not fully. Once it's dried, I'm actually going to come back with some 600 again, but without the True Oil, and I would level sand everything flat just to make sure that there's nothing sitting above the surface. It's only in the pores. Keep in mind that you may need more than one application of this, but that will all depend on whether you can actually see if the pores are filled, and I'll generally just kind of hold it up to a light, and that's generally a good way to see if there's actually stuff in the pores. It's really hard to explain on video. You'll have to try it. But once we have filled, sanded with 600 again, it's good to go into the next step of the process of applying the coats. So let's talk about making your pad for the application of True Oil. It's going to require two things. I just take an old beat up t-shirt and I'll cut a little square out of it. Basically any lint-free cloth, and I'm going to make sure it's lint-free at the edges because sometimes cutting this is good stuff. And we're also going to use a little paper towel. And when I say a little, I literally mean a little. So I'm just cut that in half, and then I'm going to cut this in half, so about a quarter of a sheet, and I'm just going to create a ball with it. And then that ball is going to go into the center of the cloth to make a little pad that you can hang on to, dip in True Oil, and then apply. The reason I do it like this is I used to do it with just paper towel, and I'd get little, no matter what you did, you'd get little tiny bits of paper here and there in your finish. So having a lint-free rag helps with that. But the bad part is with the drying oil, this thing's not really reusable, so you don't want to use anything like expensive. You don't want to make yourself a really nice one. So that's why I just use beat up shirt and a little paper towel, because everything's disposable here when I'm done, because drying oil, it's going to dry on it, this is going to remain hard, and pretty much I find that they're good for about one application. To apply the True Oil, I use a glove. It's really sticky stuff. To my knowledge, it's not dangerous, but it is kind of annoying when it gets on your hands. It's really, really sticky. I'm just going to take a little bit and apply it to my pad. And then I'm literally going to go around in circles. And I'm applying pressure. So by the time you are done with a coat, your arm should hurt a little bit. It's just like French polish. The reason for doing this is a lot of people follow the instructions on the back that says just to kind of smear it on there and whatnot, and I don't find that that works well. The reason I don't like that is a lot of people will follow the instructions on the True Oil bottle to a T. They'll just kind of wipe it on without any pressure or circular motion. It's kind of a wipe on, wipe off sort of exercise. The reason I don't like that is because True Oil goes on extremely thin, no matter how you do it. It's just the nature of the beast. And I found that just wiping it on doesn't leave you a smooth enough surface, so you'll have to go back there and do a lot more level sanding than you will doing this French polish style. The problem with level sanding True Oil is, once again, it's very, very thin, so you don't get much leveling ability before you go through it. So I would prefer to just put it on nice, thin, but even at the start than to have to come back and mess with it later. So that is why we were painstakingly polishing it onto the guitar instead of just slathering on and wiping off. And I will do this exactly the same for all parts of the guitar. Neck, back, top, sides, whatever. This is how I will go about it. And I'm going to put about 12 coats like this on total over a couple of days. And one thing I've found helps, if you look at angles and light and stuff, you'll be able to see where it's going on a little thick, or especially in areas like this where you can't really polish out. It's important to kind of come in there and sop up a little bit of that extra if there's extra sitting around. One thing that I have found that you should probably look out for is on very sharp edges, so like where the side of the headstock meets the top of the headstock. I'm going to come in here and I'm going to do the sides first, because I can't really do a swirly motion, so I'm just kind of applying pressure as I go back and forth. But what that's doing is it's squeezing oil out of my pad, and not only depositing on the side, but it's also depositing it on the face of the headstock. So right on the edges, there's now a glob of true oil. And that's why I do the sides before I do the top and back of very sharp angles like that, because now I'm going to go in and I'm going to polish the top, which is going to make sure that I don't have these globs on the side. Although true oil does go on thin, when you get those globs, they will remain relatively globs. They'll get smaller as it dries, but you will not have a flat finish, and they are going to be difficult to get out easily and cleanly, in my experience. Your final step with each coat is to take apart your pad, and what we're going to do is we're actually going to leave it to dry fully unfolded. So one interesting thing about drying oils, I'm going to see if I can do this with one hand. One interesting thing about drying oils is that they will actually heat up as they dry, and so if you keep things really balled up and folded and compacted, it'll actually build a decent amount of heat, and although rare, things have been known to spontaneously combust with drying oils. So I will just leave them there overnight, and they'll get hard, and I'll just throw them away. Since I'm going to be doing a satin true oil finish on this guitar, my last stage is to take some it's synthetic steel wool. It comes in a couple different grits. So I use the gray grit, but they also have an extra fine, I think it's called fine. They also have an extra fine white, and then they also have a red and a green, which get coarser, so medium and coarse. But I find that the gray is good for my purposes. It's relatively equivalent to Quado steel wool. And I'm going to show you what I'm trying to get rid of. So the process that we've been doing, I don't know if you can see this, I'm going to try and get this so the light catches a little. See how it's got almost like some swirl pattern in the finish? So that's left by obviously the swirling action we've done during the process. What I'm going to do is I'm just going to take my steel wool, I'm going to pick a good spot to show you guys, and I'm just going to dull this out, and it's also going to flatten it as I go. And since the true oil goes on fairly thin, as you'll see, it fairly quickly, see, there you have swirl and no swirl. So this whole area now that I just hit is swirl free, looks nice and uniformly matte. If you wanted to keep a high gloss finish, I haven't done it, but everything tells me you should probably be able to do a very high grit level sand. Like I said, true oil goes on very thin. This Quado steel wool equivalent, synthetic steel wool, is flattening. So very, very high grit level sand, and then buff if you want to buff out your true oil finishes, I'd imagine. But I've only ever done satin, and that's how I do them. I'm getting to this stage after about 12 coats. So just to go through everything again, we did the pour fill, and then I did 12 coats, no more than 3 a day, with 2 hours at least in between each of them. And then about halfway through the whole process, I did a high level grit. I think it was 800 or 600 level sand. Once again, too much grit on true oil and you're just going to go right through the stuff because it's a very thin, natural feeling finish. But I'm going to go and steel wool the rest of this, and that is actually all I'm going to do for this finish. So, no matter how well we flatten our board and ensure everything is as straight as possible when making our neck, there is going to be a little discrepancy in the frets simply because of the machining process of the frets when they're made. They could have some variances if you press harder on some frets than others, etc. There's a number of problems that can cause uneven frets. One way to find if you have uneven frets is this thing called a fret rocker. And it's not necessary for the step, but it's helpful, as you can put it over 3 frets and check if there's any sort of rocking action. and just a few that I've checked so far on this guitar seem to be pretty. There's one. They seem to be pretty good, but it's not perfect. So I'm going to go ahead and do a fret level, and then all the stuff that needs to follow a fret level to get back your crowns and make the frets pretty and whatnot. As always, first thing when dealing with the neck, straight edge, make sure it's flat. Okay, now I've gone ahead and done a couple things while you guys weren't watching. As you can see, I've taped up the fingerboard to protect it from any tooling marks. We spent a long time getting that really nice, so there's no point in marring that surface now. And I've also drawn Sharpie across the top of all the frets. And this is going to help me keep track of my leveling process. As you can see, I've also taped off my humbuckers and anything that my leveling tools may hit. Just because I'm doing it at this stage doesn't mean you have to. You can do this before finishing work, before final sanding. It doesn't really matter. And in the case of doing it before finishing work and sanding, it does give you less of a risk of marring some of your work. But like I said, in this guitar's case, this is when I'm doing it. I don't always do it now, so you can pick and choose when you want to do it. This is not a required step, but it is something that I like to do. And I'll essentially go down the fretboard using this tool. You essentially want to choose the side that bridges 3 frets so that when you rock it, and this is a precision edge milled tool, so it can pick up very slight differences in height. Essentially, I'm going to take it, pick the side that will only do 3 frets, and then I'm essentially going to try and rock it. It's hard to hear, but you can hear a little tiny shift. So what I'm going to do is I'm going to put a little dot for a little tiny shift, and then if there's a lot, I will put a line. And although this isn't a 100% necessary step, because you do have the Sharpie on top of the frets to keep track of your leveling process, I do like to do this as an extra step just to let me know where I should focus, places to keep track of. Now that I know that there is an issue here, I'll come back to this one spot, especially after doing my leveling process, and it's just an added reassurance that I'm getting the work done. Also, I should probably mention that if you are going to do this step, levelness can change across the board, so I don't just check every fret. I'll check at the edge, the center, and the opposite edge. And there will sometimes be differences. As you can see, despite all the care that we took in making our board flat, there's a bunch of spots that have little tiny rocks and a couple that have significant rocks. I'll be keeping these in mind while doing the leveling. What we're going to be using for our fret leveling is a precision milled steel rod. I got mine from StewMac. Both sides are precision milled to be pretty much perfectly flat. And that's extremely important because of the requirements for strings. Stringed instruments, they require a very uniform flatness in the frets so that you don't have buzzing anywhere on your fretboard. I'm going to use 240 grit on one side, and sometimes I will use the 320 side as well, but usually the 240 gets everything I need done. And also keep in mind there's a reason why at this point I haven't folded the edges of the tape down. Tape will actually sometimes interact with the lacquer, and if you leave it on there for an hour or two plus, it may start to lift the lacquer. The solvents of the tape may react with it and cause finish problems. So I only fold those down at the very end when I need them out of the way. For this process, I don't. And essentially all I'm going to do is I'm going to be placing the bar down and running it, making sure I keep it flat. And you can see that the Sharpie is starting to be removed in some places, while in others it's not. Some people say that you have to go one direction only. Some people say that you can put it on and move back and forth. I use a little bit of both. I don't feel that one way or the other is better or worse. Some people say that if you do the dual direction method that you'll bias a sanding to the center, and so you will have a slightly concave board. I haven't found that to be the case, but with my methods it requires so little fret leveling that I'm usually not leveling for that long or taking off any significant amount. That said, if you are, you may want to stick to the one direction method. Also, when using a rod like this, it's quite heavy, so you don't actually need to put any pressure. The weight of the rod actually does the work. I'm just literally sliding it along the surface. The longer the rod, the better, obviously, because it's going to ensure flatness. StuMac and other Lutherie supply companies also sell shorter ones that are a lot cheaper than this, and so a lot of people tend towards those. They work, but they just require, in my experience, those require a lot more patience and sometimes experience to use, because it is a lot easier to put a dip in one section with the smaller one than it is this one, because this is bridging such a long area. I'm going to keep going. We'll come back when everything's leveled. Okay, I've essentially finished up most of the leveling, and this is where having a fret rocker, despite it not being a necessity, is nice, because I can go back and check those points that were originally off. And I found that I need a little more work on the E side, and there's a little tiny bit of Sharpie left on this fret where one of the issues is that I can still see. However, it's not as good a telltale sign as the fret rocker. That said, the Sharpie would have told you that as well. It's just nice to have a way to double check and to feel it as well as see it. I'm going to go back and fix this one area by just going up the E side, obviously like before, just following essentially the path the strings would take, because our fretboard is tapered and we want it flat along the string path. Okay, and this is what our fretboard looks like now. As you can see, there may be some Sharpie left on the sides, and some places I've taken off more than others, but they all now have a distinct silver spot at the top. And that means that we are now leveled. One thing that not everybody does, but I like to do, is called fall away. It's essentially taking off more of the fret past where it meets the body, because essentially your truss rod will act on the neck between where the neck meets the body and the nut only. So you won't be putting any bow in the truss rod for this area. So some people like to put a little fall away, some people find it unnecessary. You can choose to or not, and you can always come back and put fall away if you find that you're hitting any buzzing problems in this area. But I like to do it just as a precaution and simply because I like it. So we're going to show you how to do that next. What we're going to do is we're going to put two or three levels of blue tape, 1, 2 frets out from where your neck meets the body, and we're going to level from there, and I'll show you how to do that. Okay, so now I have my 2 layers of tape, 2 frets out from where the neck meets the body, and essentially what that's going to do is it's going to raise so that it puts a differential amount of pressure down here. So you're not sanding anything up the neck, but you are sanding the frets down the neck. And we're going to do it just like we did the other process. And this is just going to take a little bit. You really don't have to put much into it. And that should be enough. We now have these flat surfaces, and that will mess with the intonation of each fret, because we want the string contacting at a single point on the fret, not over a distance. So what we're going to have to do is recrown the frets, essentially make them rounded again, so that when you press, it just contacts, the string contacts the fret at one spot. This is a recrowning file. They come in a lot of different varieties, sizes for different fret wires, and grits. This happens to be the diamond one from StuMac. It's 150 grit and 300 grit. I happen to not have needed the 150 grit yet, so I would recommend, unless you plan on doing a lot of fret leveling, which you shouldn't have to, I suggest using the 300. And essentially all we're going to do is pass it over the fret, and you'd have to go pretty intensely to mess up the level that you just did. We're essentially trying to get rid of the Sharpie marker again that I put back on each of the frets, so that will tell us that we have a rounded surface again. As you can see, I folded down the edges of the tape because I am going to have to get in and do some of these up, and the tape would get in the way. So that essentially just means that from now forward, take about an hour to 2 hours. You shouldn't need that much time, but that's just to say, don't leave this with the tape on it and come back a couple hours later or tomorrow to finish up your work. You need to do it now. And I'm just going to do a couple of these so you can watch and get the feel for how fast and what all you need to do. And there you go. That's all it took. And I have one more thing I'm going to do with this file. I'm just going to break these corners a tiny bit, just to round them over a bit. We'll finish that round over in a little while. Okay, I've now gone through and recrowned all my frets, so there is no Sharpie on the top. As you can see, on some of them there may be some Sharpie still on the sides and whatnot. That's fine. What you're doing is removing the Sharpie from the top. And this is one thing that actually kind of irked me when I first was learning this process, because I thought, if I'm recrowning the fret, how could there be Sharpie left on the side? And also another thing that bugged me is it seemed like just one or two swipes, and if my leveling was good, now I know, then the Sharpie would all be gone. I thought there's no way it's possibly doing it this quickly, or it's recrowning and leaving stuff on the side. That's not the case. And one of the things that has to do with this is, if they made a file for every single different type of fret wire, you would have to buy tons of files just to get anything done, especially as a repair person. As a builder, you could theoretically just pick one wire and build with only that. Not that that's the best option, but you could. So what they've done is they've essentially made a file that crowns it, but might not necessarily bring all different fret wire in its range of use back to a perfect circle, and that would explain why it's leaving a little Sharpie on the sides and why it goes fast. Because yes, it is crowning. No, it may not bring it back to a perfect semicircle. And if you really want to ease your mind on that, go ahead and install a piece of fret wire into a scrap. Really grind it down, like take off several thousandths, and then try recrowning it with the Sharpie method. And you'll see that, yes, on stuff that is very ground, it will take more than just a couple swipes, and you will see the line go from a thick Sharpie down the center to something thinner, 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 and finally it'll disappear. As you can see, there's a tiny little piece of that line right in there left. And if you test on a more drastic subject, you'll be able to see that better, and at least with me, that gained me some confidence in my fretwork. It may work for you, or maybe you're already comfortable with it, but fretwork does take some time. Alright, last step in the actual grinding and whatnot, shaping of frets, is to take a file with a ground edge so that it's not going to mar your surface. It's basically any file. At home I use a triangle file. I borrowed this from a friend of mine for this video because it's a nice StewMac product, but a triangle file works as well. I don't have this at home. So essentially, one non-abrasive edge and then two abrasive edges. And essentially all you're going to go around and do is just cut these little corners. Just go 1, 2, and do the other side 1, 2. That's it. And you can feel that any burring and whatnot is gone. The next step in fretwork, in my opinion, is especially grueling and time-consuming and just not fun. And as you guessed it, it's sanding. What we're essentially going to do is we're going to have to bring these frets back up to a nice polish, because the 240 that we used on the beam and then the 300 grit that we used to recrown have put lots of scratches in our fret wire. So what we're going to do is we're going to take 400, 800, and 1200 sandpaper and literally go through each of these frets and sand them up. We're not top too much, and you don't have to do that much work, but it does need to get done. And we're going to go through and do that for both sides of every single fret with 400, 800, 1200, and then we're going to rub them out with steel wool. Alright, after you've gone through all the grits that I mentioned and Quado steel wool, it's now time to buff the frets out. They're a nice satin now, and actually some people like the satin look, especially if you don't have a shiny board. If you got a matte board. If you want to polish, I use a Dremel with a little polishing pad. Also, set it up on your buffer or on a grinder, set up a small buffing wheel. The problem with using your normal buffer, like we use with the finish, on frets is that metal, when polished, makes the buffing wheel go black, and then it won't do finish because it will mess with your finishing. So I like to keep the two separate, that's why I use the Dremel. And there you go. After all the frets have been buffed out nicely, I like to take some naphtha and clean them off because, like I said, polishing frets makes this black substance. And I like to get that off the frets before I remove the tape. Once you're done, go ahead and remove it. They're done.